This is section 11.3 on Boyle's law. So we're doing the gas laws in this chapter, and this is the first one that has a scientist's name attached. And it is a relationship. It's a very simple equation, very easy relationship between the pressure of a gas and the volume of that gas. So if the pressure is higher, the volume changes. Okay. The best way I could describe it would be a stress doll. If you've ever had a stress doll where the eyes pop out, where you're squeezing like a little gummy ball and it's shaped like a critter, and you squeeze it and its eyes pop out. What you've done is you've dropped the volume. If you drop the volume but the material stays the same, then the pressure inside that goes up. So think about a gas as molecules hitting the side of a balloon. Balloons are really easy. Hitting the side of the balloon. Well, if you make the balloon smaller, those gas molecules are going to hit more frequently because it doesn't have to go as far to get to the edges, because the edges are closer in, and it'll strike more. And if it strikes more, the pressure goes up. Pressure is that push divided by the area of the push. So if the balloon's surface is the area, and I make the balloon surface area smaller, the same amount of energy will strike the edges more frequently, and the pressure goes up. So as volume goes down, the pressure goes up. So there's a relationship, inverse relationship. As one goes up, the other goes down. So as volume goes down, pressure is going to go up. They're going to be backwards of each other. Okay. This was studied by Mr. Boyle, and he got his name on it. So look at a piston. This is in your engine of your car. If you have a chamber where gas is exploding that's being burned on the inside of your combustion engine, and it raises the piston, its work is being done on the piston. As the piston goes in, okay, the engine's turning the pistons in and out. It goes in, it's going to compress those gases. The pressure goes up. As the piston goes out, the pressure drops. The volume increases and the pressure drops. Okay, so there's an inverse relationship. So as volume drops, pressure is going to go higher. So Boyle's law, if the product of P times V is a constant, as long as T and N do not change. So if you don't change the temperature, because if you made it hotter, then the heat would make it move faster and the pressure would go up. So you want to keep the temperature the same so you can see the relationship between the volume and the temperature. Okay, and what you'll see is you're going to end up as the pressure times volume at the beginning is equal to the pressure times volume at the end. There's a conservation. So as pressure changes, volume is going to change. So whatever, as P grows, V has to shrink for them to be the same. Okay, so P1 V1 equals P2 V2. That's your formula for Boyle's law. Now, the equation for Boyle's law can be rearranged for any factor, right? So if you want to solve, so here's the equation: P1 V1 equals P2 V2. Solve for the second pressure. Well, if I want second pressure by itself, I have to get rid of volume. It's being multiplied, so I have to unmultiply it. So I'm going to divide it on both sides and end up with P1 V1 over V2. And I can solve for anything. I can get one by itself and everything else on the other side, and that's how you configure for a gas problem. These are simple math. Simple math. I like simple math. Right? All right. Let's look at this in anatomy. When I teach the anatomy class, and I teach breathing, how do you breathe? Okay, you don't pump air into your lungs. Air either goes in by itself or it doesn't go in. So the way you breathe is your muscles, the big muscle called your diaphragm, drops when you want a breath. And as it drops, it makes your chest cavity bigger than it was. Well, what that means is if it's bigger, what does the volume of your chest is now bigger than it was a minute ago because you dropped that diaphragm and made it larger. And now, what happened to the pressure? If you make the room bigger, it's not hitting the moving gas is not hitting the side of the edges as frequently, and the pressure drops. Well, if the pressure drops lower than the pressure in the room, then the pressure in the room forces air from the room into your nose. Okay? Because air always goes from high pressure to low pressure. So if the pressure in your lungs is lower than the room pressure, then the room air automatically goes into your nose. So breathing is not forcing air in. All you're doing is dropping your diaphragm, and your chest gets bigger and the air rushes in. Well, how do you exhale? You make your chest smaller, right? Your costal muscles, which are in your ribs, contract, and it forces your ribs to be smaller. And when your ribs are smaller, then then your chest cavity is smaller, which means that the air in your lungs is now higher pressure than the air in the room. So when you open your mouth, air automatically comes out. The exhale is not forcing it out. It is forcing it out at the lung level. It's not forcing it out at the throat or the mouth. Okay? I think that's pretty cool. Okay? So during exhalation, your chest cavity drops, and because your chest cavity drops, the air pressure is higher in your lungs, and it automatically comes out. Okay? So here's an example of a Boyle's Law question. So they're going to give you a new volume, and they're going to give you an old volume and an old pressure and a new pressure. So you're going to be given three things and solve for the other. So solve for one, fill it in, plug it, and chug it. Okay, that's all that we need to do.
At least one copy of your textbooks.
So what you end up doing is the formula, whatever the formula is, solve for whatever you want, and then fill in those unknowns. Okay, fill in what you're given, and then solve for the unknown. That's how you solve this. Okay, I think you'll like this. For a cylinder containing helium, indicate if cylinder A or B represents the new volume for the following changes. Okay, if pressure decreases, what happens to volume? And it says helium, but I don't care. Whatever gas, any gas. Okay, if your pressure decreases, I'm not going to need as big of a space, so your volume will, or pressure decreases, okay, your volume is going to be inverse to your pressure. So if your pressure goes down, your volume gets bigger. Okay, they're backwards. If the pressure increases, right, then that means the volume decreases. So number one would be B, number two would be A. If the helium in a cylinder has 120 mils and a pressure of, so that's your original volume, your original pressure, and then you have a new volume. What is the pressure? Or you have a new pressure, what is the volume? Okay, so you're going to solve for V2, fill in all the others, and just do the math. That's what's going to happen. Very simple. We'll do these on the board. Okay. Okay, so you're going to solve for V2. You're going to get V1, P1, P2, and then just put those in, multiply top times top, divided by the bottom. You end up with 240 mils. Okay. A sample helium gas in a balloon has a volume of 6.4 at a pressure of 0.7 atmospheres. If you change the new atmospheres, okay, so you change the new pressure, what's the new volume? Okay, well, don't know the number. I'd have to use a calculator to find the number, but I know that if you increase the pressure, then you're going to decrease the volume. Okay, so I would guess A. I would guess A on that. If a sample has a volume and a pressure, what's the new volume? Okay, it would have to go down. So my guess is it's going to be the 3.2. So it's the same problem. They gave you like a picture one, and now this is the actual numbers inside it. Okay, and that's how you do it. You solve for the second volume, fill in what you know for the other three, and then just multiply and divide. That's all you're going to do. 3.2 is correct. Okay. Here's the last one. Sample of oxygen has a volume of 12 at 600 mils. What's the new pressure when the volume is 36 liters? Okay, so 12 going to 36. That's tripling, huh? If you triple the volume up and volume and pressure are inverses, then as volume increases, pressure drops by 3. If this went up by 3, pressure is going to drop by 3. So 6 divided by 3 should be 200. And it is. That's how it works. Okay? So I hope that helps.